Good morning and welcome to lesson 2.6. Well, it might not be morning for you. Anyway, we have been looking at measures of center, and in 2.5 we did some choosing of what we think is the best measure of center between the mean, median, and mode, just from thoughts. But now we're going to put some formalities to it in 2.6. This is kind of a quick lesson, but we're going to talk about this idea of skewness throughout the whole semester. And 2.7 is going to kind of put it all together. So 2.6 is another little building block. So it says in a perfectly symmetrical distribution, the mean and the median are the same or approximately the same. And when we say symmetrical, we mean either this is not what our data looks like, but something like this, where the left looks symmetrical to the right. Something like this, where again, the left looks symmetrical to the right. This is the curve that we're really looking for, where the left looks symmetrical to the right. But symmetrical, this is what we mean. So in a distribution where the mean is greater than the median, we say that the distribution is skewed to the right. So I always put the mean on the left compared to the median on the right, because the mean alphabetically, MEA, comes before MED in the alphabet. And that's how I remember to do that, because then I can follow my same rules. So if the mean is greater than the median, it's skewed right. And if you're looking at the data in a histogram, you would maybe see something like this. Or if you're looking at a box plot, you may see something like this. That would also show something that's skewed to the right. Okay, now in a distribution where the mean is less than the median, we say that the distribution is skewed to the left. So in that case, the histogram might look something like that. And your box plot might look something like this. Okay, where the tail is on the left. So let's look at an example. I have some data here. And we're going to find the mean, median, mode, and for the following data set. So the median, let's do that one first. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's n equals 9 in our data set. And because it's odd, the very middle one, it's listed smallest to largest, will be the median. So 1, 2, 3, 4, 5. It looks like 1, 2, 3, 4. 22 is the median. The mode is the data value that occurs the most, and that would also be 22. It occurs 5 times. And then let's look at the mean. And we're going to go to Desmos for that. And I'm going to just make a quick table. This is the only real data set we're looking at in this lesson, so I don't have a specific Desmos. For this one. Okay, so then I'm going to go down here and I'm just going to type mean of X1. Okay, and I'm going to validate the median is 22. So the mean is 20.56. Okay, so they're fairly close together, actually. And if we looked at this on a box plot, let's just do that. Just that's a nice way to. And let's go ahead and hit our magnifying glass. We're looking at all of our resources here. The box plot looks pretty symmetric. Okay. And interestingly enough, our median is over here, right? 22 is our median, even though you don't see that, but it is. It's the same as ours, because it's a small data set, it's the same as our Q3. And we could see that if we did stats of X1, and it's going to give us our 5-number summary. So these are all of our resources that we've been learning about, just kind of taking a look at this. So our Q3 and our median is the same. So on this particular data set, I would say symmetric, because the mean is 20.56, and it's approximately the same as the median. Again, it's a small data set. So when we say equal, it doesn't have to be exactly equal, but it's approximately equal for all intents purposes. Now, there is a second data set that I want you to look at that we've previously looked at and should be in your notes here. And that is right here. So we had looked at this data set before in lesson 2.4, I believe. And here is the box plot that comes out of that. So visually, you can see that the tail is longer on the right, which is going to be a hint that it's a skewed data set. And if we go to Desmos and go to that data, I think it might be. No. This one right here. So you can see that it's skewed. This is today's at 0.5. Yep. Okay. So if you just can't see, I didn't the extra dot over here. I'm gonna have to redo that for you all. But we want to look at the mean and the median. So let's go back to Desmos. So I'm going to just do my stats on this. And I'm going to include that right here. So it shows up. And this is X3 is my data set. So there is my median is 50. And I'm going to do the mean of X3. And the mean is 79. So let's go ahead and put that in our notes. So the mean is 79, which is definitely greater than the median. And that shows that it's skewed to the right. And so definitely you can use your box plots, but box plot will give you a good indication. And then your mean and your median comparison will definitely give you a good indication. So let's also look at our last example of a few graphs here. So we've got a dot plot. It says discuss the mean, median, and mode for each. So in this one, this would be our mode, would be the number 1. It's the one that occurs the most. And we have 20. So because it's even number, we have to find numbers 10 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to take the average of 3 and 4. And so our median is 3.5. And without putting all these values into Desmos, we could see that our average is going to be higher. It's going to be skewed right because of these data values here. So we would not even really need to put our data in to find the mean, but we could tell that this is going to pull the mean skewed right. Okay, let's look at the ages former US presidents died. And this looks very symmetric. And we could turn our picture this way if we wanted, but it looks pretty symmetric. the mode on this one, let's see. We've got 57 occurred 3 times, 67 occurred 3 times. So it's bimodal because we've got 57 and 67 occurred the most number of times. And then the bottom histogram here, this is definitely a skewed left. It looks like the majority of our data is up here, and then we've got some few data values down here. So it's definitely skewed left without actually looking at the mean and median. We can also visually see that the mode is in this category, the 20 to 24.99 class. So using the idea of comparing the mean to the median, make sure you're putting the mean on the left, that will give you an idea if your data is skewed or not. And if our data is skewed, then we're going to use the median as our best representation of our data, the best measure of center. And we're going to put that all together in lesson 2.7. So catch me back for that.